since we did line segment, yes, AB yesterday, let's do line segment MN. Line segment MN. Now I'm going to put this on my coordinate plane up here, and then we'll work this one together. We need to find the length of this line segment MN. So I've got to put together all of my markers again. Okay. MN. This is M, and N is right here. Now this is the way, oh, here my shoes. Mine are just sucking. Okay. And so the line segment through these 2 points is here. And this is what it looks like on your worksheet. And the instructions are to find the length of line segment MN. Move this a little bit. Got things in the way. Yeah. Letting you know also that I'm going to start leaving the ringer on my phone, leaving it on in case I miss some of you that are coming in later. You can just call me. Well, get my little app together. Chuck. Sorry, y'all. Chuck is missing. All right. The first thing that we need to do when we're finding the length of a line segment is we need to know the end points. We need to know the address of the end points. So if we found the address or the coordinates of point M, we need to start like we talked about yesterday. We start at the origin. We move in the horizontal X direction first. And so I'm moving 1, 2, 3, 4. -4. Because I moved in a negative direction. And then when I get here, I need to turn the corner and go down 1, 2 blocks. So -4, -2 are the coordinates of point M. We also need to know the coordinates of point N. So again, starting at the origin, I need to move in a horizontal direction, 1, 2. And I turn the corner and walk 1, 2, 3, 4, 5, 6, 7, 8 blocks in a negative direction again. And so our 2 points, the 2 endpoints of the segment that we're referring to are M, which is -4, -2. I need to check and make sure I'm in, if I did that correctly. Yes. Okay, and in the coordinates for that point are 2, -8. Now, when you know the 2 endpoints, you're able to find the distance or the length between the 2. And the way you do that is to use the distance formula. The distance formula is D for distance equals the square root of y2 minus y1 squared plus, are we getting all this?
No. Yeah.
There we go. Plus x2 minus x1 squared. Now, the place that we get all these X's and Y's are from the coordinates of the end point. We know that when we have coordinates of a point, this is X and this is Y. That always will be the case. They go in alphabetical. Pardon?
That X will always come before the Y?
Yes, ma'am. Okay. Alphabetical order, if you need to remember that. So the X is always first and then the Y in all of these points. So now, since we're going to use these X's and Y's in this formula, we need to be able to keep them separate. So we're just going to number one of these points will be the ones, X1, Y1, and the other one will be X2, Y2. Now, don't worry whether you get these two mixed up and you call this X with X2 and Y2, that's okay. And then you call this X1 and Y1, it will still work in the formula. Do not call this X1, Y2. Okay, the ones and ones have to be in the same point, and the twos and twos have to be in the same point. Y'all understand? Okay, if you mix those up, then it won't work. So now all we have to do is plug into the distance formula to find the length of the line segment MN. D, the distance, is going to equal the square root of, now I'm just copying this formula, and when I get to a variable, I'm going to substitute its value. So Y2, I go up here and find the Y2, -8, minus Y1 is a -2. Now I need to call your attention to this again. Notice that there's a minus and a negative. You need to make sure when you need both of those. This minus comes as part of the formula. See this minus, but when you get to this place, you need to put what the value of Y1 is, and it has a negative on it. So you're going to have minus and a negative in this one. Plus X2 is 2 minus a -4. So we're going to have minus and negative on both of those. Now, the first thing that you're going to do in this order of operations is we need to work what's in parentheses first. And I'm going to go ahead and work the parentheses and the exponents at the same time. So we have -8. Remember, you can circle the two negatives and make those positive. So -8 plus 2 is a -6. And I want to square a -6. So I'm going to have a positive 36. Remember, anything squared will be a positive answer. Again, I have two negatives together, which make a positive. So this is 2 plus 4 is 6 squared is 36 also. Sometimes if you want to make sure that things stay inside the square root radical, you can use this little lip, because sometimes we have things inside and then some more things on the outside. So you'll see this sometimes. Okay, now we're going to add underneath the radical, which will be 72. Since we don't have a perfect square, since we don't have a perfect square for the square root of 72, what we're going to do is find the square root using your calculator of 72. Now, yesterday I showed y'all when I used the calculator to find the square root of 72, it gave me another square root answer. But the instructions on this worksheet say to round the answer to 2 decimal places. Then I need a decimal. So on these calculators, it's wonderful because it has a toggle switch right here above the enter. It's right, oh good heavens. Huh, everything's backwards. Has a toggle switch. If you will push this toggle switch once, then it will give you the decimal equivalent to the square root that we just had. So now we have 8.485. Let me get my chalk where it needs to be. 8.485. 8.485 is what it comes out. And then some more numbers. The reason I just wrote these is because they ask you to round to the nearest 2 decimal places. So this is all they want for the answer, 1, 2 decimal places. However, before you write your final answer down, you need to look at the outsider here and decide, is it big enough to shove this up to a 9? Or should I just leave this to be an 8? And I heard the correct answer back here. If the outsider here is 5 or above, then you definitely do push this up to the next number. So your answer, D, is approximately, this little equal sign that's curly cubed like this means approximate, and it means that you have rounded your answer. 8.49 would be the length of segment MN. Don't know again. Someday I'll be able to put all of this on the same screen. Maybe. Okay, up here, you're rounding 8.485, blah, 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 blah. This is all they want. Look at the outsider and it says to round this up. If this is 5 or above, you need to round that number up. So your answer that you would give here is 8.49 approximately.
How do you get D? Where do you get D?
D has been what we were finding all along, distance,
Oh, distance.
distance, and distance.
Okay.
I'm just copying the D down, and the D stands for distance or length.
Okay.
All right? Now, I'm going to use this same line segment to show you the midpoint formula. And you will be happy to know that the midpoint formula is much, much easier than the distance formula. And the distance formula isn't bad. Okay, what they're wanting you to tell them, they're wanting you to find out the exact middle. They want the address of the exact middle of this segment. They're wanting you to find out where the exact middle is. So let's say it's probably somewhere in here. Doesn't it look like half and half? But they're wanting you to find out what are the coordinates of this midpoint. All right. Now, sometimes you could approximate it and say, it kind of looks like it's there, but we want an exact midpoint. This is kind of cool because it's very easy to do. Again, we're going to work with the same points. And N, the coordinates for N are 2 and -8. To find the midpoint is this easy, okay? The midpoint is going to be an X and a Y, okay? And the way you're going to find it is to find the average of the X's. How do you average something? Do you guys know?
You add them and divide by the number.
Always find our grade averages by ourselves. So you would add up all your grades and add by how many, or divide by how many grades there were. anyhow, to find the average of these x's, this is x1, y1, x2, y2. Okay, so the actual formula says x1 plus y, x2 over 2. So it says just add the x's and divide by 2. So, and the y is y1 plus y2, and you're going to divide that by 2, and that's it. So let's take x1 and x2. I have a -4 plus 2 divided by 2 is going to be this x coordinate. Then I'm going to take these two. I have a -2 plus a -8. Yeah, -2 plus a -8, and I'm going to divide by 2. So when I get this, -4 plus 2 is 2 over 2. -2 plus a -8 is a -10 over 2. And so our midpoint equals 2 over 2 is 1. -10 over 2 is -5. Let's see how close we got. This is the address of the midpoint of segment MN. So 1, -5. Let's go graph that. So if I graph that point, I have 1. Uh-oh, Deborah's done something wrong. Negative. There it is. There it is. Okay.
The negative.
It's a negative. -4 plus 2 is a -2, Deborah. Okay. Try again. So the midpoint should be -1, -5. 1, 2, 3, 4, 5. And that is the exact midpoint between these two endpoints. It's -1 and -5 is the address or the coordinates of the midpoint of this segment. How do y'all feel?
I got that before you even did that, just because I was looking at the graph, just eyeballing it.
Right.
And so I just went back to where it looked like it was about even, and I went backwards -1 to the midpoint and went down -5 on the y.
That is wonderful. But there will definitely be times that it might be -1 and 1/10 and -5 and 3/7. So it won't always be a whole number. Okay, but yes, you did a great job there. And that's what I did here when I was just estimating and looking to see about halfway. And then when I did the actual calculations, then I came back to see how close I was. Okay, it's kind of a game. Let's go. Actually, now, do y'all have any questions about the midpoint? Midpoint?
No, I'm good.
Boris, you okay?
I do.
Okay.
On the, where you did the x1 plus x2,
Yes.
and then you got a 2, how did you get the 2 on each
Right here?
one? And okay, you marked the line under it, and then you got a 2?
This is divided by. Two.
Divided by, so 1, 2
Divided by.
divided by 1 is 2? 1 divided by 2.
Okay, you have to add first.
Uh-huh.
So I picked out my x1 and x2.
Okay.
Okay, and I added those. You add those first and get an answer, which now you know is -2. And I put it divided by 2. -2 divided by 2.
How did you know to divide it by 2?
Because this is the actual pattern formula that you follow. And part of the formula itself says to always divide by 2.
Okay,
That's how you find the average.
okay.
Okay. Yes, that's a good question. Yeah, the 2 actually came out of the formula.
Okay.
Like if you look at your formula chart and it says how to find midpoint, it'll say on there. So you don't have to memorize it. And it will have this divide by 2 in the actual formula. So if it's in the formula, you have to use it
Okay,
the way it's used.
okay,
So it didn't come from any calculations.
okay,
Okay, it came from the actual formula that you copied.
okay.
Okay, and Doris, I was asking you if you're okay.
Yes, ma'am, I'm okay.
All right, let's go to an actual page. I'd use that example off of the distance page. Let's go actually to your midpoint page, which if you numbered your pages, it's 8, page 8. I guess I'm gonna have to just hang on to chalk and marker.
It's 7. Find the midpoint.
Find the midpoint. Mhm. It will be this one, says midpoint formula. And the number, it actually gives you the formula. Do you see that there, Brandy?
Yes,
Okay, see, the 2 is just a part of the formula.
okay.
Okay, that's what makes it work. Everybody else, this is the page that we're going to look at. I'm going to do number 1, but we probably ought to do number 2 because it's going to scare you because it has fractions in it. Doesn't need to scare you, but I know y'all. So we're going to do number 1 first and find the midpoint. Now I'm not going to graph it until the end, and we'll look at that and see how close we were. So I have 1 point. That is 7, 1. And the other endpoint of the segment is 2, -9. Okay, and I want to find the midpoint of this line segment. And so my formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. We know these are xy, always will be, xy, and I'm going to number them so I can keep them separate. So my midpoint is going to be x1 plus x2, 7 plus 2 over 2, comma, then I'm going to add the y's, 1 plus a -9 over 2. And then all we have to do is the math. So I have 9 over 2 and -8 over 2 because I add here. And then when I list these in the answer, you can either list a fraction in its lowest terms, or you can change this to a decimal. Either one is correct. So this one will be 4.5 if we change to a decimal. If you leave it as a fraction, reduce the lowest terms, it would be 9/2. -4. This is the point halfway between this point and this point on the graph. So this could be your answer, or it could look like this. Both of these are correct. Can either be decimal or fraction form. Okay, either one is fine. I see you all, I see your faces as you're working through this. So look at these and see if you have a question while I graph this. The first point is at 7, 1. And the other one is at 2, -9. So this is where the actual line segment is. Oh, not too bad. And then if we try to guess, okay, I see you. Come on in. Okay, if I'm going to try to find halfway here, I'm just going to eyeball this. And up close, it's kind of weird. I don't know. About here, guys?
Yeah, so about
Looks,
right there.
looks good. Okay, now that I have done the mathematics, let's actually plot this point and see how close I was. Because I'm finding the halfway point, midpoint. So 4.5 would be 1, 2, 3, 4.5 is here. And then I'm going to go a -4. 1, 2, 3. Are we good? There's the midpoint right there. Yes? How do y'all feel?
I like it, but after class, I want to just kind of get with you a little bit.
Okay, it's just following the formula.
Yeah.
And then again, it's negatives, adding and subtracting negatives, right?
Yeah.
Yes. Okay. Hi, Sherry.
Good morning. I'm sorry I'm so late.
No, that's okay. You told me every day, except one day, I can't remember, you're going to be late because you're in a different city now and you have to take your kids to school at a different time.
Yes.
So I haven't told the rest of the students, but you'll probably be 30 minutes late every day, except which day?
Friday. They don't have school here on Friday.
Friday. They don't have school where she's going, where they live now. Okay. So this is how to find the midpoint and the length or distance. And if there are no questions here, we're going to move to this second packet 2 that I sent to you yesterday. We're going to talk about the types of slopes. The types of slopes. Okay. So there are 4 main types of slopes. But first, let me tell you exactly what it means, what the slope actually means. Slope is the slant of a line. Okay, it's just the slant of a line on the graph. Okay, so there are 4 different types of slopes. I'm going to draw the little graph here. Now, every time I'm looking at a slope, I start left to right, like I'm reading a book. So if I have a line that is slanting from low, this is called a positive slope. And the opposite is true if I have a line that starts high and moves low, then this is a negative slope.
This is because we're starting from left to right.
Yes,
Okay.
yes. That used to mix me up, so I started telling everybody it's like reading a book. We read left to right. I'm going to read these lines left to right. Okay, now the next one is a completely horizontal line. And we will have some of those maybe today. A complete horizontal line
Be a no slope.
I am going to pause this recording. Okay, we're back. The third type of slope is a completely horizontal slope, and this is called a zero slope. Now, these last two slopes, students sometimes get them mixed up. So I'll give you an idea how to memorize the difference. And then if you have an absolute vertical slope, a vertical line, then this is called a no slope. They also, probably you will see it written as undefined. An undefined slope, okay? It's very important for you to remember that a zero slope and a no slope are absolutely different. A no slope isn't zero. It's nothing. It's got an undefined slope, a vertical line. Okay, now, if you get these mixed up, the way I learn these is the Z right here. I can make this line, I can make it the start of a Z. I don't know if this helps you at all, but it helped me. You can make a Z out of a horizontal line. You can't make a Z out of this. But when you come to a vertical line, you can make an N out of a vertical line, but you can't make a Z out of it. Don't know if it helps. Undefined, you can actually make a U out of this. Undefined, can't make a U out of that line. So I don't know if that helps, but you can tell the difference between those. Sometimes you get those mixed up. Okay, any questions? 4 different types. Now you'll have some questions that actually say, it'll show you a graph and say, what kind of slope is this? And you just have to say positive, negative, zero, or undefined. Okay, and as we move on, we're going to find out that if we're looking at a graph itself, we can find the slope by counting the rise, how many blocks we rise, and how many blocks we run. Here's an example. Okay, if I have, let's go here, and then okay, here are 2 points. And now, we're talking about lines now. So the line will go through the point and continue on forever and ever. Now, if you have at least 2 points on a line, you can find the slope. Now, I want to point out that when we were plotting points, just finding the address, we always started at the origin. Remember? The 0, 0. When we're finding slope and we're counting slope, we need to start from one point and end up at another point. Y'all see? So slope and plotting a point are 2 different things. Everybody okay with this? Okay. So to find the slope of this line right here, I'm going to pretend that this is my house. This is my friend's house. And the slope is my GPS, how to get there. So I'm going to start from my house, which is right here. Okay. And I want to go all the way to my friend's house. Okay? And the reason I'm putting this dotted line is because my lines aren't exact like the coordinate plane. So here's my house. I'm going to walk out the front door. And I know that if I need the slope, I need to rise first. Now I can have a positive rise or I can have a negative rise. Okay, this time I need to go to this point. So I'm going to have a positive rise and I need to count how many. I walk out my front door. I don't count my house. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 blocks to get to the intersection where I have to turn. So I went 11 blocks in a positive direction. Okay. I rose from my house. Then I look at my watch and I'm late, so I have to run to her house. So I'm going to run 1, 2, 3, 4, 5, 6. And now I'm at her house. So I ran 6 blocks. So my slope is 11 over 6. That's it. Okay, now the only thing that you might change is if this fraction itself could be simplified, then you'll simplify it. But rise over run, and keep in your head that plotting points is completely different from counting slope. Everybody okay with this for right now? Okay, I'm going to look at the pages because we're not going to go through this whole packet right now. I want to give you some things to look at over the weekend. A reminder one more time, tomorrow there will not be class. So our next class will be on Monday. Let's see here. Okay. So the first page of your worksheet simply says, all you have to do is look at it. And on the line, you tell whether it's a positive slope, a negative slope, undefined, or a zero slope. Are y'all on the same page I'm on? This one? But sheet 1 says types of slopes.
Yes.
So all you have to do here is say positive, negative, zero, or undefined. Then, okay, so I'm going to do, so page 3, I'll come back to page 2 in just a second. We're going to do it today, and then that's all we're going to do. So page 3 says find the slope, and all you're going to do is start at one of the points, count your rise over your run. Go from one point to the other, from your house to your friend's house. That's all you're doing on this page. All right, that's that counting. I want to show you something on that. Yes, that's all you're doing on page 3. I want to show you something on that. Then I'm going to show you page 2. And we will stop there. Okay, on this that we just did, I said it doesn't matter. Just pick one of the points and go to the other point. So let's say last time I started here, like this was my house going to my friend's house. Well, let's say I live here and I want to go to my friend's house. Let's see if it's any different. So I need a rise and a run to find the slope. So I'm going to start at my house now. But in order to get to her house, I'm going to have to rise in a negative direction this time. So I'm going to go 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 11 before I turn and run. So I went in a negative 11 direction. Now I'm going to turn and run because I'm late. And so I've got 1, 2, 3, 4, 5. I think it's like this. My little numbers are messed up. So I turn and run. 1, 2, 3, 4, 5, 6. And I end up at her house. But when I ran in a negative direction. So I ran a negative 6.
So it's the same, just a negative.
So 2 negatives make a positive, and so the slope of this line is still positive 11/6. Positive 11/6. It does not matter which point is on the line. Okay? It doesn't matter where you start. Okay? You go house to house on the slope. Just plotting a point, you always start at 0. Okay? And one more way to find slope, and we're not going to go through this whole packet. This will be what you do on page 2 in your worksheet. I am still going to find the slope. The slope is still going to be a fraction. But what if they don't give you a graph? What if they just give you 2 points? So I'm going to make up 2 points right now. Well, no, let's find the slope of this line. Okay, does this still show? We're going to find the slope of this line that we messed with before. So in order to do this, I have to know what the coordinates are. This is 7, 1. And this point is 2, negative 9. This will be a different formula. A different formula. Did I do that right? 2, negative 9. This will be a different formula, but it's also on your formula chart. So to find slope, and on your formula chart, they will probably call it M. M stands for slope. The formula says to take y2 minus y1, the y's go on top, x2 minus x1. That's it for the slope. So the 2 points that we're going to use are 7, 1 and 2, negative 9. Again, this is x and y. This is x and y. These are the 1s. These are the 2s. So now all I have to do is plug into the slope formula. So slope equals y2 is negative 9 minus, because that's in the formula, y1 is 1 divided by x2 is 2 minus 7 x1. And then you just have to work the problem. So negative 9 minus 1 is a negative 10 over 2 minus 7 is a negative 5. We know that the negatives, 2 negatives make a positive, and 10 divided by 5 is 2. So the slope of this line is 2 over 1 because you need a rise and a run. You will see it sometimes. They'll just give you the 2. But you should always make your slope be a fraction, rise over a run, using this formula right here. Any questions? Y'all have questions?
No, ma'am.
No, ma'am.
Okay with these?
Yeah, I'm good with it.
Okay, Luanne?
I'm good.
Okay. Sherry Sue? You're on mute, should,
Yes, ma'am.
okay. Okay, and Doris, you okay?
I'm okay, thank you.
What I would like for you to try to do between now and Monday, kind of catch up on some of your other work, because I know all of you work and all of you have families and there's just so much. So use this long weekend, since we won't have class tomorrow, to try to catch up. And in this slope packet number 2, I would like for you to do page 1, 2, 3. You can do 4. You can try page 5 if you want, or you can wait. So at least the first 4 pages, you have the information you need. Any questions?